Let's evaluate the first limit. We have a limit of absolute value of x over the x, and x approaches 0 from the left. For this, I'm going to use the definition of the absolute value of x, which I have given over here. That is, the absolute value of x equals x if x is greater than 0, and it is equivalent to negative x if x is less than 0. And since here we see that the limit, we have to evaluate the limit when x approaches 0 from the left, it is basically less than 0. So we will use this definition, that is absolute value of x equals negative x in our limit. So I'm going to replace this this absolute value of x as negative x, and we already have a x in the denominator. I write like this. So this is x approaches 0 minus. Now we can clearly see that we can cancel this plus negative x with positive x, and this equal to negative 1 times. So therefore, we basically have a limit of x approaches 0 minus, that is, x approaches 0 from the left of minus 1. This negative 1 is basically a constant. So limit of any constant is equivalent to the constant. So therefore, the final value of this limit is equivalent to 1. So we just got the value of this limit. This is negative 1. Let me write down here. The value of this limit is negative 1. Let's evaluate the second limit. So we have a limit of x squared minus 7x plus 12 over 3 minus x, and x approaches 3. So for that, we can do the direct substitution first. And when we do the direct substitution, we get, I'm going to let x replaced by 3. So in the numerator, we will have 3 square is 9, and 7 times of 3 is 21, plus 12 we have over 3 minus 3. So basically we get 9 plus 12 is 21, 21 minus 21 is 0. So, and in the denominator also we have 3 minus 3, which is 0. So we get into a form that is 0 over 0. This is basically an indeterminate form. So as of now, we could not use the direct substitution. So we use other methods. One of the other method is we go for the factorization of the terms either in the numerator or in the denominator or both. So this will help us reduce the rational fraction into simplest form, and then we can evaluate the limit. So for that, I'm going to factorize this quadratic expression in the numerator, that is x squared minus 7x plus 12. This can be written as in product form as x minus 3 times of x minus 4, which I'm going to replace into the limit. So therefore, the limit becomes limit of x approaches positive 3. Then I can replace the numerator as x minus 3 times of x minus 4 over 3 minus x. And I'm going to rewrite this 3 minus x as this can be written as negative of x minus 3. We basically factorize negative 1 from the two terms. So therefore, this can be written as like this. So the next step, I can in fact clear this, replace this as negative of 3 minus x, which let me do here. So therefore, this becomes negative of x minus 3. Now we see that we can cancel this x minus 3 with this x minus 3. We then have this negative. So let me write down in the next step. So this can be written as x limit of x approaches 3 x minus 4 over negative 1. Now we can do the substitution. Let me substitute x equal to 3 into this expression. So therefore this becomes 3 minus 4 divided by negative 1, and this gives 3 minus 4 is negative 1 over negative 1, and this is positive 1. So the value of this limit is positive 1. Let me mark it over here. We now evaluate this third limit. So we have limit uh, x approaches infinity, 1 minus x over 1 plus x. So if you do the direct substitution in the numerator, it will become negative infinity over positive infinity. This is an indeterminate form, so we cannot use the direct substitution. And I'm going to rewrite this in a different form, that is a limit of x approaches infinity. negative x plus 1 over x plus 1. This is just a different form of the same expression. Now we can use the method that by going with the degree. So we look at the degree of this numerator, which is 1, and the degree of the denominator is also 1. So when we have the degrees equal, we can simply take the coefficient of the x, or the highest degree of the x. Here it is negative 1. So this is equivalent to negative 1 over the degree of this denominator is x, and its coefficient is that is the coefficient of x is positive 1. So we take only the coefficient and we do the division like this. So therefore this becomes negative 1 over 1 equals negative 1. So the value of this limit is negative 1. Clearly we can see that only the limits given in first as well as 3 are getting the value of negative 1. So therefore the answer to this question is the first as well as the third limits are equivalent to negative 1, which means option B is correct.